Good morning. I'd like to work through the periodic table practice assessment with you. So the first question, what pattern do you see in the valence electrons in the groups, which are columns? So let's scroll down and take a look at the columns in the valence electrons. We see in group 1, all elements have one valence electron. Group 2 is not good to look at. In group 3, we have all elements have 3 valence electrons. Group 4 has the same thing. So we do see a pattern. The elements of the same of each group have the same number of valence electrons. Number 2, what pattern do you see in the valence electrons in the periods or rows? So we'll scroll down and take another look. So we start on the left side. The first column has 1. Third column has 3. Fourth column has 4. Fifth column has 5. You move to the right, the valence electrons increase by 1 each moment. What pattern do you see in the mass? So as we scroll down, you see the mass is 6.94, 10.81, 12.02, 14.01, and 19. Next row, 22.99, 26.98, 28.09. So as we move to the right, we can see an obvious pattern that the mass increases. Number 4, what pattern do you see in the atomic numbers? The atomic numbers 3, 5, 6, 7, 9, 11, 13, 14, 15, 16, 17. So similar to the valence electrons, as we move to the right, the atomic numbers increase by 1. Number 5, how could you predict the melting and boiling points for unknown elements? So the one easiest way that we found in our discussion last week to find the melting and boiling points was to look at the neighbors and find a value that is about in the middle between the neighbors. So we would look for that is in between the neighbors. So now that we've got our guidelines in terms of using patterns to find these properties of the undiscovered elements, let's go through and work on finding the patterns of the undiscovered, or the properties of the undiscovered elements. So for undiscovered element A, the atomic number, we've got 3 before it, 5 after it, which makes the atomic number obviously 4. To look at the mass of undiscovered element A, we'd look to see 6.94 before, which is about 7, and 10.81 after it, which is about 11. So the middle between 7 and 11 is about 9. Now there's a range of possibilities here. I would count 8 correct. I would count 10 correct, okay? Because we're just estimating with our predictions. The melting point would be about in the middle between 180.5 degrees Celsius and 2077 degrees Celsius. So the midpoint would be about 1,100. If you were to put something a little larger, something a little smaller, that would be fine as well. There is a range of correct answers. And the same thing with the boiling point. It's going to be somewhere between 1,330 degrees Celsius and 4,000 degrees Celsius. The midpoint would be about 2,500 degrees Celsius. Again, somewhere in the middle, in between would be fine. So there's a range of correct answers for undiscovered element A for the melting and boiling point. Now again, the valence electrons, we've got a very easily identifiable pattern, right? We said in the first column, all of the undiscovered elements have, or all the elements have a valence electron of 1, and in the third column, it's 3. So that would make undiscovered element A would have 2 valence electrons. And we've completed undiscovered element A. For undiscovered element B, you would do the same thing. The atomic numbers between the neighbors, so between 33 and 35, we would predict undiscovered element B has 34 protons for an atomic number of 34. The mass is generally between 75 and 80, so a good estimate would be 77. If you were to put 76 or 78 or 77.5, all those would be fine as well, because they're generally in the middle. The melting point would be somewhere between 817 degrees Celsius and 7 degrees Celsius. An estimate for the midpoint of that would be about 400. And again, we have a range of correct answers. Boiling point would be somewhere between 600 and 59. So about 350 is the midpoint. And valence electrons, we are in the 6th column, so it would have 6 valence electrons. Draw the electron into the diagrams of the missing elements. So missing element A. We go up and we see missing element A has atomic number 4, which means it has 4 protons. And because we are working with neutral atoms, it also has 4 electrons. So I'll need to draw in 4 electrons. I know that we start with the innermost energy level, and it has room for 2 electrons. So we've accounted for 2 of the 4 electrons. We move out to the next energy level, which has room for 8. So we will easily be able to fit our other 2 into the second level. So missing element A's electrons would look like this. Start in the first level for the first 2, and we have 2 remaining, which would fit into the second level. Missing element B is going to be kind of a mess because we have 34 protons in missing element B, which means we also have 34 electrons. Okay? So again, the first energy level has room for the first 2. The second energy level has room for 8, and it doesn't matter where you place them on the energy level as long as you have the correct number. 3, 4, 5, 6, 7, 8. So we've accounted for 2 in the first energy level, 8 in the second, for a total of 10. We have room for 18 in the third energy level. So we will place 18, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So again, to review, we've got 2 in the first level, plus 8 more in the second for a total of 10, plus 18 in the third for a total of 28. I don't have an energy level for the the fourth. However, we still have 6 left over we need to place. So we'll just randomly place them and pretend we have one out here. 2, 3, 4, 5, 6. So we have placed all 34 electrons in missing element B. Missing element A was much easier, and the 2 missing elements that you will work with, C and D in the periodic table in your summative assessment, will be much more manageable than missing element B was. I hope this was helpful.